Okay, so I'm Agatha, and I'm going to do the second part of this lecture. So I'm still going to do in the chapter 2 and end the chapter 2 of this book. So I'm going to talk about prototypes and do a little summary of what we've talked about during this chapter 2. So first, I'm going to talk about prototypes, and before I want to define what a schema is. So schema is a conceptual structure for organizing concepts. So it means that you have ideas and it's a concept inside your mind, and a schema is the way to put it in a writing way. And it's very important and very fundamental if you want to communicate between engineers and to have human expertise. Schema is the best way to communicate because it's not easy to tell people what the concept you have in your mind. So for example, we have this a database schema. So you all know what database is, and you have like a lot of information, and the connection between all the tables in your database are very complicated, and a schema is a way to put it in a simple way, and so everyone can look at the schema and understand quite quickly what you want and what you're meaning and what you want to do. So schema is very powerful and very useful for designing, but also for other stuff. So before, when a designer is going to design some projects, he always begins with very few information. He already know what he wants to do, and he needs to begin the design to know what to have all the information and important information who's going to come. Only relevant information will manifest itself only if you start to design. If you don't have everything you want and everything you need before starting your design, you need to look for it while doing your design. So designers will begin the design with a very minimal set of information, and you need to know this when you're doing your design. And the prototypes will be the designers, when they start designing, they have some ideas, and because they have an experience or they had classes, they know some stuff about engineering. So prototypes will be what they're going to start to do when designing, and it's a schema of all the knowledge and the design knowledge they have, and they're going to put it into a schema, and that's what we call it a prototype. So the prototype would be like description of general design, and the design you want to produce will be inside this class of design, and so you can use the prototypes that you have to describe this class of design. So it can be, the description can be used with vocabulary, interpretative knowledge or syntactic knowledge, and interpretation or requirement. So to have it like in equation like we had before, we can have, you see that the prototype is a function of the design you want to produce, the vocabulary you have, the interpretative and syntactic knowledge, and also the requirements you want to do when you're doing your design. A designer will have his own knowledge, and so he has his own prototype. But many designers have the same knowledge, because engineering or mechanical knowledge will be like, there's no different rules. So we can have they can tend to agree to boundaries, the same boundaries. They need to discuss to each other, but like the same like-minded designers, we have to tend to have the same prototypes or similar prototypes. So for an example, this is a house prototype. So you have interpretation, that's the requirement. You want to provide a living for a family, but after it can have it can be modern or Spanish, and it can have a different style, different cost. So your prototype can be, I can say that you can have different, it's a prototype would be like the beginning space of design, you have. And so it can be with low cost or medium cost, and it can be with different style. And then you have the vocabulary. So you need to have kitchen, living room, bedrooms, bathrooms, etc. And a description. So it's a building. You can have 1 to 3 stories. And then you also have the design, the knowledge. So you know that if there's a kitchen, then you want to have a dining room next to the kitchen. That's the syntactic knowledge. So you know how to place things next to each other. And you have the interpretative knowledge. So if the house has this style, so you interpret the style of the house, then you can say it's like a Spanish house, or I don't know. So that's an example of a house prototype. So it's the space of design you're going to start when you're designing a house. Then you can do refinement. So if you have the space of design, so you know you want to be inside this, then you need to reduce the space of design to finally have one design, the one you want. So to do this, you can, in the description, you can have variables, and you want them to have values. So when you do prototype refinement, you are choosing those variables, maybe creating new ones, and determine the values. It can be numerical values or symbolic. So the equation we saw in the professor daughters can become only from the prototype and interpretative knowledge, you can have a new design. So you're beginning from the space of design you have at the beginning, and you use your interpretative knowledge to have a new design. So if the values and the requirement are numerical, you can use the optimization method to have your new space of design. But if they're symbolic, you need to use something else. And you can use, for example, the routine design. It has a cookbook or recipe. Routine design is using a recipe. It's a design that if you want to make an application, for example, you have already a recipe of how to make a new application on the internet, and researchers have done already research on this. So routine design is using the method of someone already created to do a new design. So for example, this is the initial prototype of space of design for a knife. So you have like the interpretation, so you just want to cut. The portability can be difficult, the safety can be dangerous or safe, etc. And the description, so it can be a weapon or a tool, it can be for hunting, kitchen or picnic, or etc. And so when you do refinement, if you want to do a knife for picnics, you need to create new variables and have them add values. So you have all the new variables, and you just want to, so it's a picnic knife, it's in plastic, it's have this length, it's this color, etc., etc. So that's prototype refinement, just beginning from a space of design and having something more particular. But then you can also have prototype adaptation. So if the original prototype or space of design is not completely, or you know that the design you want to produce is not completely inside this space of design, you need to change some of the vocabulary or syntactic knowledge. So you need to move your space of design and changes maybe its form, or I don't know. And you need to do this before refinement. You're changing your space of design and then reducing this space. So this is, you create a new prototype. So for example, if you have this, you start with a hunting knife, and actually you want a pen knife. So the hunting knife is something dangerous, big, difficult to go around with. So, and your pen knife is something you want to be small, you want to be safe, but you want to be easy to use. So you need to adapt your space of design, the first prototype. So you need to do adaptation, and then you have a new prototype with this pen knife. Then you have the prototype generation. If you want to build something new and you don't have any space of design originally existing, then you need to create a new space of design, a completely new one. So prototype refinement is inside the space of design, you're searching for something particular. Prototype adaptation, you just change a bit of the space of design because there's some particular thing that don't agree or don't sit. And then yes, prototype generation would just be something completely new and with very new in the vocabulary, syntax, knowledge, and everything. So, but frequently generating a new prototype would be many prototype adaptation at the same time. So it's so different than you have prototype generation. So this is the example in the book. If you want to have something to slice eggs, there's knife already existing, but they don't slice them very well. Or there's razor, but that's not safe. So there's some stuff already existing, but it's not something you can use easily. It's not something you want to design. So you're using those prototypes that already exist, and you have your own objective, which is completely different from the original objective of knife and razor. And so you're going to inspire your new space of design with the knife and razor, but you're going to, so you want something safe like knife, you want something that cuts well like razor, and so you have those vocabularies like razor and handle to be safe, and then you're going to do a new syntactic knowledge, so to know how to put the razor and the handle together to have something that cuts eggs well. So you're creating a new space of design with new knowledge and new vocabularies. So that's prototype generation. I talked about prototype with schema, but you also probably know physical prototypes like this. And this video maybe not have it's talking about the different physical prototype, if it's work. Okay. I don't know. So it's working. It's explaining more the physical prototype, what it is. But you need to know that you can do prototype adaptation, refinement with also physical prototype, and it's maybe easier sometimes for engineers if they really want to work on something physical to see. So. Oh no. So yeah, that's 3 types of prototypes that she's presenting in her video, and I don't have any time to like see all the video, but you have the link in the slides. And so this is what prototype is. And so now I'm just going to do a summary of what we saw during all this chapter. So first we saw what was objects, and so the objects and relationship between objects or facts, and that the knowledge would be a relationship between facts, and that we know and that we can create new facts with relationship between facts. We also saw that knowledge, most of knowledge is actually hidden. It's implicit representation, so it can be in existing design or in generic design or in procedures, etc. So you need to really keep this in mind, that you need to look for knowledge. We saw that there's a very simple, the simplest model of design would be generate and test, like we just saw before. So you're employing the syntactic knowledge to create a correct design, something that has the relationship between parts would be okay, and then you use your interpretative knowledge to have performance and to see that your design is working or not. So that's just what Professor explained just before. But you need to remember that knowledge about design process it's action, so you need to do a lot of things, but you also have to control everything. You need to know what you have done, you need to know how to navigate through the knowledge you had during this design, and to make the right interference between the facts and between the vocabularies and between the design parts. So, yeah. Do you have any questions? Nope.